So, today we'll discuss about small SQL. Today's outline we'll be discussing about command. Then we'll see some set operations. Then we'll see what is meant by nesting of queries in SQL. Then aggregate functions. We'll be seeing some aggregate functions in SQL, arithmetic functions. So let's see the use of distinct. So we know that SQL does not treat a relation as a set. So as a result of that, duplicate tuples can appear in a relation. So how to eliminate the duplicate tuples in query result? And for that purpose, we can use the keyword distinct. For example, suppose we have a query. The result of this query may have duplicate salary values, and whereas the next query does not have any duplicate values. For example, Q11, query Q11, that will select salary from employees. So it will select all salary from employees. But Q11A select distinct salary from employee. So its meaning is that it will eliminate duplicate salary values from the query result. We will be getting only distinct salary values if you use this distinct keyword. And let's see some set operations now. SQL has directly incorporated some set operations. There is a union operation, there is a union. In some versions of SQL, there are set difference, that is a minus, and we have intersection operations also. And the resulting relations of these set operations are sets of tuples. Okay. And again here, the duplicate tuples are eliminated from the result. And the set operations apply only to union compatible relations. So when we say we are applying this set operation, that can be done only to union compatible relations. What is meant by this union compatible relations? We are performing some set operations on two relations. Then these two relations must have the same attributes, and the attributes must appear in the same order. Then only this union or the set operations make sense. And consider a query that is make a list of all project numbers for projects that involve an employee whose last name is Smith as a worker or as a manager of the department that controls the project. We need to get the project numbers uh, for projects, and the condition is that all these projects should involve an employee whose last name is Smith, or and that Smith can appear as a worker or as the manager of the department that controls the project. So query will be like this: select P name. So here we are returning project name, and from, so we need to get a project name, and we need to check whether that person's or that employee's last name is equal to Smith. Okay. So we need to compare, or we need to take project relation, then we need to take the department relation, and then we need to take the employee relation. So here the condition is where dnum is equal to d number, and manager SSN equal to SSN, and LNAME equal to, will be getting all the employees, I mean all the projects who has an employee and whose last name is Smith. So that is manager SSN equal to SSN. Here the Smith is a manager, and union, and this set should combine with another set where this person is a worker. So union again select P name, from project work zone and employee, and where P number equal to PNO and ESSN equal to SSN. ESSN is a foreign key in this work zone relation, and their L name is equal to. So if he is working as an employee for some particular project, then his if his that particular project name will be returned. So we'll take two sets. That is, one is where Smith is a manager, another one is Smith is a normal employee, the worker, and we'll be combining these two. This will perform union operation on these two. And next is nesting of queries. So we have uh, suppose a complete select query called a nested query, and that can be specified within the where clause of another query called the outer query. So when we say this nesting of queries, we have an outer query, and inside that we have a complete select query that is known as a nested query. And many of the previous queries that we considered earlier can be specified in an alternative form with nesting, which makes it easier. So that is, we can see one query that is retrieve the name and address of all employees who work for the research department. We have seen this example earlier, and how we wrote that is we need to select F name, L name, and address from employee and department, where D name is equal to research and D number is equal to DNO. That was the condition, or that was the query. And here we are trying to write this using nesting. So select F name, L name, address from this employee, where DNO, DNO in. DNO is actually a foreign key in this employer. So DNO in select D number. So here a complete select query appears within this outer query. Okay. So select D number from department, where D name is equal to. Here, when D name is equal to research, that particular D numbers will be taken. And we are searching, or we are checking whether this DNO appears inside this set. Okay. That is the case, then the corresponding F name, L name, and address will be returned. So that is the nested query selects the number of the research department. Then the outer query selects an employee tuple if its DNO value is in the result of either nested query. So if this DNO is inside this set, then that particular employee tuple will be selected. And the comparison operator, we have a comparison operator there, that is in, that compares a value small b with a set or a multi-set of values capital B and evaluates to true if v is in one of the elements in B. So we have this operator in that it just checks whether value B is in capital B. Okay. And if that is uh, there, then it will return true. And in general, we can have several levels of nested query. Okay. So that is meant by a nested query. And when we talk about this nested queries, we can talk about, or we can define a correlated nested queries. So if a condition in the where clause of a nested query, what is meant by this correlated nested query? What we are trying to define. So if a condition in the where clause of a nested query references an attribute of a relation declared in the outer query, the two queries are said to be correlated. So we have a condition in the where clause of this nested query. And if that references an attribute of a relation declared in the outer query, we have an outer query, and this condition references an attribute of a relation. We have the relation there in the outer query, and this particular condition in the where clause references an attribute in the relation declared in the outer query. Then these two queries are said to be correlated. And the result of a correlated nested query is different for each tuple of the relations of the outer query. We'll see. Retrieve the name of each employee who has a dependent with the same name, with the same first name as the employee. That is what we need to output. So that is here select f name, I mean e dot f name, e dot l name from employee as e. So we are using aliasing here, where e dot ssn in select essn from dependent, where essn equal to e dot ssn and e dot f name is equal to dependent underscore. So this will return the name of employees who has a dependent whose first name is same as name of the employee. And the nested query has a different result for each tuple in the outer query. In this case, nested query has a different result because this will return this will return this will return a different tuple for each different result for each tuple in the outer query. So a query written with nested, nested select from where blocks and using the equal to or in comparison operators can always be expressed as a single block query. For example, we can rewrite that as Q12 select F name L name from employee E dependent D, where the condition is E dot SSN equal to D dot ESSN and E dot F name equal to D dot dependent underscore name. Here our condition says that if it is a correlated nested query, then only thing is if a condition in the where clause of a nested query references an attribute of the relation in the outer query. So we have this where clause, that is actually select ESSN from this dependent relation that actually references an attribute of the relation in the outer query. This E name, this employee relation also has this SSN as an attribute. Okay, so that's what it is, a correlated nested query. And when we talk about this original SQL, and that had another operator that is known as a contains comparison operator, and that is used in conjunction with nested correlated queries. Okay, and this operator was dropped from the language, possibly because of the difficulty in implementing it efficiently. We had this contains comparison operator, and this most implementations of SQL do not have this contains operator. The contains operator compares two sets of values and returns true if one set contains all values in the other set. That is the purpose of a contains operator. For example, that is actually a reminiscent of the division operator of algebra, operation of algebra. So retrieve the name of each employee who works on all the projects controlled by department number 5. So select F name L name from employee, where select PNO from works on, where ESSN equal to SSN contains select P number from project, where D number equal to 5. So this is the query that will return the name of each employee who works on all the projects controlled by department 5. So this will take all the projects under this department 5, and that is combined with this query. That is, it will just select PNO from this works one, where SSN equal to ESSN. That will be returned, and that is combined with this F name with this employee relation, and will be returning this F name and L name. So here we can say that this particular query, that is this second nested query, that is select P number from project, where D number is equal to 5. Here it will return this project number that is not a correlated nested query because this does not have or this does not reference to this outer query. Okay, but this select PNO from work zone where SSN equal to ESSN actually does. That is in this query, then second nested query, which is not correlated with the outer query, retrieves the project numbers of all projects controlled by department 5. The first nested query, which is correlated, retrieves the project numbers on which the employee works, which is different for each employee tuple because of the correlation. So we know that when the correlation occurs, we will get different tuples. Okay. So this will select PNO and that has a correlation with F name and the employee and that will return different uh, tuples. And we have this access function. So the access is used to check whether the result of a correlated nested query is empty. That is, it contains no tuples or not. So we can formulate query 12 in an alternative form that uses. So our query 12 was to retrieve the name of each employee who has a dependent with the same first name as the employee. So that is retrieve the name of each employee who has a dependent with the same first name as the employee. So select F name, L name from employee where X is, select star from dependent where SSN equal to ESSN and F name equal to dependent underscore name. Okay, if this is not null, then it will return F name and L name. Okay. So if it is null, then this employee relation will be returned. This, for example, the retrieve names of employees who have no dependents. So there is another version also. We have not access. Retrieve the names of employees who have no dependents. So select F name, comma L name from employee where not access. Select star from dependent where SSN equal to ESSN. So here the coordinated nested query retrieves all dependent tuples related to an employee tuple. Okay. If none exists, the employee tuple is selected. Okay. If um, none exists, which means that particular employee does not have dependents. Okay, then the particular employee tuple will be returned. And access is necessary for the expressive power of SQL. And we have another option that is the explicit sets. So it is also possible to use an explicit, that is a enumerated set of values in the where clause rather than in nested query. So that is, for example, retrieve the social security numbers of all employees who work on project number 1, 2, or 3. So we can have an explicit set of values here. So for example, select distinct ESSN from work zone where PNO in 1, 2, 3. Okay, so that's what it says. Who work on project number 1, 2, or 3. That is, select distinct ESSN from work zone where PNO in 1, 2, 3. And we can have nulls in SQL queries also. So SQL allows queries that check if a value is null. If a value is null means the value is missing or that is undefined or maybe not applicable. So SQL uses is or is not to compare these nulls because each null value is distinct from other null values. So equality comparison is not appropriate. Okay, so each null value is distinct from other null values. So it uses an is not comments. Okay, so for example, query 14, retrieve the names of all employees who do not have supervisors. So select F name, L name from employee where super assistant is null. And one more condition. So if the super assistant is null, it means that the particular employee doesn't have a supervisor. So their F name and L name will be returned. And when we perform a join operation, what will happen with the null values? Okay. So tuples with null values for the join attributes are not included in the result. Okay. That's what happens in a join. Then we have aggregate functions. Okay. So what is meant by this aggregate functions? So these aggregate functions are used to summarize information from multiple tuples into a single tuple summary. There we can use a grouping, and that is used to create subgroups of tuples before the summarization. And grouping and aggregation are required in many database applications. And we have a number of built-in um, this aggregate functions exist like count, sum, max, min, etc. So the count function returns the number of tuples or values as specified in a query. And sum, max, min, average can be applied to a set or multi-set of numeric values and returns the sum, max, min, and average respectively. Okay. So here consider an example. Find the maximum salary, the minimum salary, and the average salary among all employees. So select max of salary, min of salary, average of salary from employee. Okay. And in some SQL implementations may not allow more than one function in the select clause. Another function, another query, find the maximum salary, the minimum salary, and the average salary among employees who work for the research department. Okay. So again, max salary, select max salary, min salary, average salary from employee and department because we need to get the research department. So where DNO equal to D number, how to join them? DNO equal to D number and D name is equal to research. And we have next query, that is the retrieve the total number of employees in the company. We can write it like this, select count star from employee. That will return all the tuples. So it will count all the tuples. Then it will return the total number of employees. And we'll get the total number of employees from employee rotation. And the number of employees in the research department. So there count star from employee and departments where condition is DNO equal to D number and D name is equal to research. Okay. So we need to get the total number of employees in the research department. And we have this grouping also. Grouping is used to create subgroups of tuples before the summarization. Okay. And this in many cases we want to apply this aggregate functions to subgroups of tuples in a relation where the subgroups are based on some attribute values. So, for example, we may want to find average salary of employees in each department or the number of employees who work on each project. In all these cases, the subgroup is dependent on a condition, okay, are based on some attribute values. Okay. So in these cases, we need to partition the relation into non-overlapping subsets or groups. Okay. Groups of tuples. And each group will consist of the tuples that have the same value of some attributes called the grouping attributes. So here each subgroup of tuples consists of the set of tuples that have the same value for the attributes, and that attributes are known as the grouping attributes. And the function is applied to each subgroup independently. And SQL has a group by clause for specifying the grouping attributes, which must also appear in the select clause. Okay. So that is for each department, retrieve the department number, the name of employees in the department, and their average salary. So select DNO count star, that is to get the number of employees in the department. Okay. Then the average salary from employee group by DNO. So what happens here? It, it groups this based on this condition. This is a grouping attribute, DNO. Department number is the grouping attribute. So based on this, uh, what we said is each subgroup of tuples consists of the set of tuples that have the same value for the grouping attributes. Okay, so that kind of subgroups. So department number wise, we'll have subgroups, and the functions apply to each subgroup separately. So each uh, employee will be grouped based on their department number. So we'll be counting that particular subgroup, okay, and that particular average salary. The employee tuples are divided into groups, each group having the same value for the grouping attribute DNO, this is department number. Then the count and average functions are applied to each subgroup of tuples separately. Then the select clause includes only the grouping attribute and the functions to be applied on each group of tuples. And a join condition can be used in conjunction with grouping also. So, for example, we have for each department project, retrieve the project number, project name, and the number of employees who work on that project. So select project number, project name, and count star from project works on where project number equal to PNO. That is how they are connected. Group by project number and name. Okay, so we take all subgroups based on project number and project name, and we'll be counting employees uh, in that particular or who work on that project. Okay, so here in this case, the grouping and functions are applied after the joining of the two relations. These two relations must be joined. Then after that, this grouping and these functions will be applied. And we have this having clause. Sometimes we want to retrieve the values of these functions for only those groups that satisfy certain conditions. Okay. That is, we need to apply these functions for only those. We have some subgroups, but we want to apply this or we want to retrieve the values of these functions for only those groups that satisfy certain conditions. And the having clause is used for specifying a selection condition on groups rather than on individual tuples. That is, for each project on which more than two employees work, retrieve the project number, project name, and the number of employees who work on that project. Okay. We need to get the project number, project name, and number of employees who work on that project. And for each project on which more than two employees work, that is a condition. So select project number, project name, count star from project works on where project number is equal to PNO, and this should be grouped by P number comma P name and having count star is greater than 2. That's what we say. If there are more than two employees, then only we need to retrieve this project number and name. Then we can have a substring comparison. And the like comparison operator is used to compare partial strings. Means two reserved characters are used. is a percentage or star in some implementations. Okay, replaces an arbitrary number of characters and a hyphen replaces a single arbitrary character. We have percentage symbol and a hyphen symbol. So for example, retrieve all employees whose address is in Houston, Texas. Here, the values of the address attribute must contain the substring Houston, comma Texas. So, because we are asked to retrieve all employees whose address is in Houston, Texas. That is address. A part of this address is Texas. That's what we check. Value of the address attribute must contain the substring Houston, comma Texas. So select f name, comma l name from employee where address like operator is used here, that is to match substance. So for that we use this percentage Houston, comma Texas percentage. Okay, so that will replace an arbitrary number of characters. We'll have so many characters here, but we'll have a Houston, comma Texas. If we are using a hyphen, that I mean underscore, that replaces a single arbitrary character. That is, retrieve all employees who were born during the 1950s. Here, 5 must be the eighth character of the string according to our format for date. 5 must be eighth character. So the birth date value is this eighth value and eighth character with each underscore as a placeholder for a single arbitrary character. So we are checking this 5 only. So what will happen? Select F name, L name from employee where B date like 5, 5 at the eighth character. And the like operator allows us to get around the fact that each value is considered atomic and indivisible. Hence, in SQL, character string attribute values are not. And we have arithmetic operations also. The standard arithmetic operations plus, minus, then this multiplication, division. All these are can be applied to numeric values in an SQL query result. So show the effect of giving all employees who work on the product X project a 10% raise. Okay. So select F name, comma A name. So we need to increase the salary by 10%. So 1.1 into salary from employee works on project where SSN equal to ESSN and PNO equal to P number and P name equal to product X. There we can apply this arithmetic operators like this. Then we have order by. That is, the order by clause is used to sort the tuples in a query result based on the values of some attributes. This order by that is used to sort the tuples in a query result. So, for example, retrieve a list of employees and projects each works in, ordered by the employees department, and within each department, ordered alphabetically by employee last name. So that is, we need to order by employees department and employee last name. So select D name, L name, that is department name, last name, first name, and P name from department employee works on a project where D number equal to DNO, SSN equal to ESSN, and PNO equal to P number. Then order by D name, comma, last name. Simply we can put this the order by and you can list the attributes there. It must follow this particular order. And the default order is in ascending order of times. So when we just write it as order by, it is ascending order. And suppose we want to get a descending order. We have a keyword that is DES and the keyword AST for ascending. That is used to explicitly specify ascending order, even though it is the default. You can use ASC, there is no mistake. But if we use DSC, that means it is a descending order. So that's all about